The story of atomic structure begins with the discovery of electrons by J. Thomson. He identified the first subatomic particle, proving that atoms are not indivisible. Next came Ernest Rutherford in 1911. His gold foil experiment revealed the nucleus, a dense, positively charged core in the center of an atom. This led to the discovery of protons. Finally, in 1932, James Chadwick discovered neutrons, explaining why atoms of the same element could have different masses. These three particles form the basis of atomic structure. Hello everyone, my name is Aryan and today we're going to be diving into one of the most fundamental concepts in all of chemistry, atomic structure. Understanding this concept is essential because atoms are the building blocks of matter. By the end of this video, you'll know what atoms are made of, how they are organized, and why their structure is so crucial for understanding properties and reactions in chemistry. Let's dive in. So what exactly is atomic structure? Atomic structure is the detailed organization of an atom, the smallest unit of an element that retains that element's properties. Atoms are incredibly tiny, but they're very complex. They have a central nucleus and surrounding particles. This structure helps explain how atoms interact with one another, why some elements react vigorously while others don't, and how atoms bond to form molecules. Imagine an atom as a tiny solar where the nucleus is the sun and the electrons orbit around it, forming a sort of electron cloud. Let's explore each part of this structure. Atoms are composed of three main subatomic particles: protons, neutrons, and electrons. Let's break them down. First, we have protons. Protons are positively charged particles that are present in the nucleus or the atom's core. Each proton has a charge of +1, and the number of protons, known as the atomic number, defines which element the atom represents. For example, hydrogen has 1 proton, while carbon has 6. The proton count gives each element a unique identity. Next, we have neutrons. These particles are also located in the nucleus and have no electric charge. Neutrons help stabilize the atom by balancing the repulsive forces between the positively charged protons. Without neutrons, the nucleus would be unstable, as protons naturally repel each other. Finally, we have electrons. Electrons are tiny particles with a negative charge of -1 and are found in the space between the nucleus, known as orbitals or energy levels. They move quickly, forming what's called an electron cloud around the nucleus. While electrons don't have much mass, they play a huge role in chemical reactions and bonding by either being shared, lost, or gained. The balance between protons and electrons makes an atom electrically neutral. Alright guys, now let's clarify two key terms: atomic number and mass number. The atomic number is simply the number of protons in each atom, and it's unique to each element. For example, each atom of oxygen has an atomic number of 8, meaning that it has 8 protons present in its nucleus. The mass number, on the other hand, is the sum of both the protons and neutrons present in the nucleus. Since both protons and neutrons have mass, the mass number gives us an idea on the atom's weight. For example, if a nitrogen atom has 7 protons and 7 neutrons, the atomic mass would be 14. Remember, while the atomic number identifies an element, the mass number tells us about its mass. Now that we know about protons, electrons, and neutrons, let's discuss electron configuration. Electrons are arranged in specific energy levels or shells around the nucleus. Each shell can hold a certain number of electrons, and the further the shell is from the nucleus, the more number of electrons it can hold. The capacity of each shell follows the formula 2n squared, where n is the shell level. For example, the capacity of the first shell is 2 electrons. The second can go up to 8, and so on. This arrangement is known as electron configuration, which determines an element's reactivity. Let's take sodium with an atomic number of 11. Its configuration is 2 in the first shell, 8 in the second shell, and 1 in the third shell. Because sodium has 1 electron in its outer shell, it's very reactive and will tend to lose that electron when forming bonds. This configuration is crucial for predicting how many elements will react with each other. Alright guys, now that we know about electron configuration, it's time to talk about isotopes and their applications. Isotopes are atoms of the same element with different number of neutrons. For example, carbon-12 and carbon-14 are isotopes of carbon. Isotopes have existing applications in fields all the way from archaeology to medicine and even industry. Carbon-14 is commonly used in carbon dating, which is a process to determine the age of buried ancient artifacts. Uranium-235 is critical for nuclear power and medical imaging technologies. Iodine-131 helps in the diagnosis and treatment of thyroid conditions. Understanding isotopes helps us unlock scientific and medical advancements. Now, let's build a simple model of an atom to see these parts in action. Gather small items like beads or buttons for protons, electrons, and neutrons. Let's build a lithium atom. Guys, a lithium atom has 3 protons, 4 neutrons, and 3 electrons. Let's begin. To start with, let me explain the structure to you. The center part, the nucleus, will contain the protons and neutrons. Shell 1 and shell 2 are the electron orbits where the 2 electrons and 1 electron will sit. So, to begin, let's place 3 beads, buttons, or coins into the center to represent protons. So today I have 3 coins that represent protons. Now the next step is to add the neutrons. Lithium has 4 neutrons, for which I have 4 coins. So now the nucleus of our lithium atom is ready. It has 3 protons, the gold coins, and 4 neutrons, the silver coins. Next, the electrons. The first shell contains 2 electrons. For electrons, I have these white table tennis balls. Now, can you guys tell me why does this atom have 3 electrons? Drop your answer down in the comment section. Now for the second shell, the third electron. Now guys, this cluster over here represents the nucleus, and these shells and these balls represent the electrons. This basic model lets you visualize the atomic structure. Obviously, it's not perfectly to scale, but it helps us understand how atoms are structured. And that's a wrap on atomic structure. Today, we explored basic parts of an atom, the protons, neutrons, and electrons, and learned about atomic number, mass number, and electron configuration. These basics lay the fundamentals for understanding chemical reactions, bonding, and the properties of different elements. If you have any questions, feel free to drop them down in the comments. And don't forget to like and subscribe if you found this helpful. And stay tuned for more chemistry content. Thanks for watching, and I'll see you guys in the next video. Bye-bye.